due now is a dimensional analysis problem, and we want to complete that problem using the conversion chart provided. A news report suggested that an adult should drink a minimum of 4 pints of water per day. Based on this report, determine the minimum amount of water an adult should drink in fluid ounces per week. So in our dimensional analysis problem, we're going to start with our first rate, which is 4 pints per day for 1 day, and we eventually want that to get into fluid ounces per week. So we want pints to convert to ounces and days to convert to weeks. So we might start with our pints as we go through. So we want to look for something that helps us convert from pints to ounces. So first thing we should see is that we know 1 pint is 2 cups. So we're going to multiply by that conversion factor. We want the pints unit to cancel, so the 1 pint has to go in the denominator, 2 cups will go in the numerator. But we don't want cups as our final answer, we want ounces. So then we want to use our conversion factor. That 1 cup is 8 fluid ounces. So again, we want cups to cancel, so that 1 cup is going to go in the denominator with our 8 fluid ounces on top. Now we need to get from days to weeks. So we know that there are 7 days in 1 week. We want days to cancel, so our 7 days is going to go in the numerator to cancel with days that's in the denominator for 1 week. Now to check that everything cancels, I like to go through and just make sure, oh, pints and pints cancel, cups and cups cancel, day and day cancel, and we'll be left with ounces and weeks. Now all we need to do is multiply everything in the numerator, multiply everything in the denominator. So in our numerator, that's 4 times 2 times 8 times 7, which gives us 448 ounces. And in our numerator is all 1, so that would be 448 ounces per week. On the Regents exam, these are typically multiple choice questions, but nice to go over and do one all the way out to. Okay. Today we're going to start looking back at our polynomials. So some things we want to remember is that standard form, we're always writing our answers in standard form, which means we're writing the term with the highest degree first, down to the lowest degree. Right? And when we talk about degree, that's the sum of the exponents in a term, or the last thing is always the constant, which would be degree 0. Also nice to remember our vocabulary for degree, like 2 degrees is quadratic, we've got degree 3 cubic, degree 4 quartic, our degree 1 is linear, and degree 0 is our constants. Okay. Number 2, we're asked an expression of the 5th degree is written with a leading coefficient of 7 and a constant of 6. Which expression is written correctly? So leading coefficient of 6 and its degree, leading coefficient of 7 and its degree 5. So that might be answer choice 2 or 4. And it says it's got a constant of 6. So that's going to be answer choice 4. Okay. Getting back into our operations, when we're subtracting polynomials, really important that we're distributing the negative to whatever the second term is. So we can write the first term in parentheses if we want, right, where we're doing this a minus b, where a is 3x squared plus 5x minus 6. But the second term has to be in parentheses so that we see we're subtracting each term, or that we're distributing the negative to each term in that second polynomial. Once we distribute that negative to each term, now it's just a combining like terms problem. Right, and we're obviously writing our answers in standard form. So that's going to give us, that should be 13. 5x squared plus 11x minus 13. Okay. Multiplying our polynomials, that's where we're using that double distributing, triple distributing, whatever it might be. So we've got, what is the product of 2x plus 3 and 4x squared minus 5x plus 6? So we're doing a binomial times a trinomial. So this is going to be double distributing, where we're distributing the first term to everything in the parentheses. So 2x times 4x squared is going to give us 8x cubed. 2x times negative 5x, negative 10x squared. 2x times 6, 12x. Now we are going to distribute the 3. So we get 12x squared minus 15x plus 18. And I just wrote that underneath the like term. This way we can just go ahead and add. Everything's lined up for us. Okay, so that should give us 8x cubed plus 2x squared minus 3x plus 18. So answer choice 3. I really like this question here, number 5. When 2x minus 3 squared is subtracted from 5x squared, the result is, so if we start by just translating this expression, right, subtracted from, that's where we're going to subtract and we're going to switch the order. So that's going to make this 5x squared minus 2x minus 3 squared. But we first have to do this 2x minus 3 squared. Now remember, we can't do power to a power. We have to actually go and expand that out and do our 2x minus 3 times 2x minus 3. So we're doing all of our double distributing. Okay, so that should give us 4x squared minus 6x plus 9. 4x squared minus 12x plus 9. Okay? And we're subtracting, so that's still going to stay in parentheses until I can distribute that negative to each term. And then we can just combine our like terms to get x squared plus 12x minus 9, which would be answer choice 3. Now going on and looking back to our arithmetic sequences and our geometric sequences. Remember, arithmetic sequences is when we're adding by an integer each time. That could be a positive or a negative integer. And our geometric sequence is where we are multiplying by a number each time. That number could be an integer, it could be a fraction, so the sequence could be getting bigger or it could be getting smaller. In this first group of problems, we're asked to determine whether it's arithmetic or geometric and then write an appropriate rule for it. So looking at A, I want to notice going from negative 11 to negative 6, we would do that by adding 5. And then from negative 6 to negative 1, we would add 5 again, which shows us because we are adding, this would be an arithmetic sequence. Right? So we're going to use that formula A sub n equals A sub 1, where A sub 1 is your first term, plus D, the common difference, times n minus 1. So we would write A sub 1, our first term is negative 11, plus our common difference D, we just said was 5, times n minus 1. In B, going from negative 5 to 15, you could add 20, but 15 to negative 45, no, that doesn't work. You must be multiplying by something. So that's going to be a geometric sequence where we see we're multiplying by negative 3. That's how we're going from negative to positive each time. Another way you can determine that common ratio, what we're multiplying by, is to take one of the, like the second term, which is 15, and divide by the first term, which is negative 5. So you're looking for that ratio, and this reduces to negative 3. Okay, so this is clearly a geometric sequence, and we're going to use that geometric formula. Right, our first term is negative 5, and then we've got our common ratio, negative 3 to the n minus 1 power. Okay. For C, where we see going 80, 40, 20, 10, 5, you can clearly see it's not getting smaller by adding, right? Some people think of this as dividing by 2, but but our common ratio we're always multiplying. So we have to realize dividing by 2 is the same as multiplying by 1/2, and that might be one of those places where you set up your ratio to determine you're multiplying by 1/2. Okay? So again, this one is geometric. So we can set up our sequence a sub n equals 80 times 1/2 to the n minus 1 power. Okay. On D, going from 40 to 31 to 22, we should see that this is reducing by a common difference of -9. Right? So we're adding -9 or subtracting by 9 each time, which makes this an arithmetic sequence. So we can make our sequence a sub n equals 40 minus 9 times n minus 1. And now we're just looking at a few examples of some problems we could see with our arithmetic and our geometric sequences. The first 3 terms of an arithmetic sequence are 9, 16, and 23. Which of the following would be the sequence's 20th term? So you could list out all the numbers, but probably easier is to set up a formula for your sequence. To do that, we have to find the common difference. So 9 plus 7 gives us 16, 16 plus 7 gives us 23. So we know D is 7. We're given the first term is 9. So we're able to build our sequence as a sub n equals 9 plus 7 times n minus 1. So if we want the 20th term, n is our number of term, we put 20 in for n, so we say a sub 20 is equal to 9 plus 7 times 20 minus 1. So a sub 20 equals 9 plus 7 times 19. Okay. So 7 times 19 is 133. And 9 plus 133 is 142. So the 20th term would be 142. Okay. Then we've got 8. In a geometric sequence, the first term is 5 and the second term is 20. Which of the following is the 5th term? So we know the first is 5 and the second term is 20. So going from the first to the second, we would be multiplying by 4. Okay? So that means R is 4. Easy enough, you could just kind of multiply this out, but I want to do it with our geometric sequence formula. So that's going to be a sub n equals, our first term is 5. Our common ratio is 4 to the n minus 1 power. So looking for the 5th term, a sub 5 equals 5 times 4 to the 5 minus 1 power. A sub 5 equals 5 times 4 to the 4th power. Right, so 4 to the 4th is 256, so that's going to be 5 times 256. So the 5th term would be 1,280. Answer choice 2. Okay. And then number 9, kind of a different problem with our arithmetic sequence. I'd be surprised to see it on the Regents, but you never know. Given the arithmetic sequence a sub n equals -4 plus 7 times n minus 1, what term in this sequence is 689? So we know 689 is in the sequence, but we don't know what number term. So that means n is going to be our unknown. We're going to take 689 and substitute it in for a sub n so that we can solve for n. Okay, so that's going to be 689 equals -4 plus 7n minus 7. Combine our like terms. 7n minus 11. Add 11 to both sides. You get 700 equals 7n. Divide both sides by 7. And n is equal to 100, meaning that 689 is the 100th term in the sequence.